2. We're going to learn the derivation for each of these equations. Why am I showing you the derivations? Technically, you could just learn these off, but if you actually understand how we got each one of these equations, it's more likely that you would remember it correctly, right? Instead of just memorizing an equation that I gave you just because you have to. It's always good to understand where it came from. That would increase the chances of you actually remembering the correct equations, right? So the first one, V is equal to U plus AT. That's what that's what I'm gonna show you. How did they get that? Where did that equation come from? Well, it's actually quite simple. So we're required to prove that V is actually equal to U plus AT. How did they get that? Well, from my equation for acceleration, when we were doing the intro to kinematics, we said acceleration is the rate of change of velocity. And my equation for acceleration is actually A is equal to V minus U on T, the rate of change of velocity on the time taken. V is my final velocity, U is the initial, T is the time taken between these 2 points, A, acceleration, right? We did this already. So how did they get this? Well, they actually just rearranged this equation. I would multiply both sides by T. So I'll actually end up with AT is equal to V minus U. I want to make V the subject. So AT plus U would give me V. But I can rearrange it to look exactly like this. That's no problem. So I'm just use blue. V U plus AT. You might be wondering, somebody might be wondering, but how come you didn't put AT plus U? Well, addition is actually commutative, right? You should know this. So if I say 2 plus 3, we know that's 5. That's the same as saying 3 plus 2. The answer would still be 5. That's why addition is commutative. It does not matter which order I put the numbers in, 2 plus 3 or 3 plus 2, my value or my result would be the same, 5. So that's why I can say AT plus U is the same as saying U plus AT. And that's actually how they got the first equation of motion. Do you understand now? I forgot I'm using both of them. What did I miss? You didn't miss anything. Good afternoon, Trey. You didn't miss anything. Do you understand this first derivation? Oh, for the people who just came, we are doing the equations of motion, and right now I'm showing you the derivation for each one of them. This, V is equal to U plus AT, is the first equation of motion, and I just showed you how exactly they got that equation. No, I didn't know the derivation. You don't understand what I just did? This?
Wait, after what we're doing, I just switch up from school.
Equations of motion.
Equation of motion, hard. But topic's not that too hard.
Okay, so what I said, because here late, I'm trying to prove the first equation of motion, right? Just now, you were just here. I told you there are 5 equations of motion. Instead of just learning them off, I'm going to show you the derivation for each. So how did they come up with each of these equations? It didn't just pop out of the nowhere, right? It just, you need to understand how they got it. They didn't just wake up one day and say, oh, that looks nice, let me just use that. No. From our the definition of acceleration that we learned a while ago is the rate of change of velocity. How do we represent that? We said that A is equal to V minus U on T. V is the final velocity, U, initial velocity, T, the time taken between those 2 points. And of course, A is my acceleration, right? We did that before. So how is this equation that I already know, so my equation for acceleration, how is this related to this? How did they get that? They actually just rearranged the equation to make V the subject. So I multiply both sides by T. So I would get AT is equal to V minus U. But like I said, I want V to be the subject. I want V by itself. So I would add U to both sides to get AT plus U is equal to V. But just rearranging it to look exactly like this right here. V is equal to U plus AT. And I was explaining just now, someone might be wondering, why didn't I just leave it as AT plus U? I mean, technically, it's the same thing, right? But this is just the standard way of writing the equation of motion. And I can, in fact, do this, switch them around. Why? Because addition is commutative, and that's where this example comes in. If I say 2 plus 3 is equal to 5, 3 plus 2 is also equal to 5. So I can have these two numbers in any order, 2 plus 3, or I could say 3 plus 2. The answers, it would still give me 5. The answer is still 5. It doesn't matter which order I put the numbers in, I would still get 5 because addition is commutative. That's why A plus AT plus U is the same as saying U plus AT. That's my first equation of motion. Do you understand that? You transposed. Yes, it's called transposing, which means to make something the subject of an equation.
Yes, we understand.
Okay. The second equation, okay, can I clear this? Can I clear the screen? Yes, no.
Yes, miss.
Okay. Right. Hold on. Check the chat. Okay. Second equation of motion. So RTP means required to prove, right? RTP. Second equation of motion is S is equal to a half. Okay. Come on, why is it not working? U plus V by T. Like I said, these equations didn't just appear out of nowhere. There's actually a way to derive this equation right here. All you need to do is consider a velocity time graph, right? That's what we were learning before, velocity time graph. So I have my y, let's just pretend it's a straight line. My x-axis, time in seconds. My y-axis is velocity in meters per second. Let's just say I draw a graph, or they gave me the graph, and it actually looks like this. I'm starting at this point, I'm going all the way up to, let's just say, a point here. They told me the value of the velocity at this point right here. This would be u, my initial velocity, meaning the velocity I start off with, right? This point, so I'm going from this point to this point. This here would be considered v, my final velocity. Let me just draw. Right. The time, let me a different color. And let's just label this t. T is the time taken from this point to this final point. So let me just use some numbers just in case you're not understanding what's going on. Let me continue. So this is what my graph looks like. Hold on. V, T, let's say they actually told me, so I'm using numbers here, right? That I'm starting with a velocity of 2 and I'm ending, so going from this point to this point, my velocity is 5. Obviously, at the origin, t would be equal to 0 seconds. But then at this point here, it's 4. So what does that mean? From here to here, from this point here to this point, it took me 4 seconds. And what do we also know about a velocity time graph? Well, the area under the graph, which would be, let me use this one. The area under the graph, which is this orange region here, is the distance traveled, or you might consider it the displacement, right? Let me just represent it. Let me highlight this. Let me say it's S. Do you understand so far before I continue? Is there a way for me to? Well, let me see if there's a. I don't think there's a way for me to do that. Anyways. Yes, yep, yes, cool, nice. So let me continue. If they ask me to find S is the distance traveled, or let's just consider it the displacement in this case, right? Because if you actually look at the past papers, they might ask you, find the total distance traveled, or find the displacement between t equals 0 and t equals 4. They really just mean the area under the graph, right? So it's okay. If I want to find the S, we know it's the area under the graph, S. And what shape is this? This is a trapezium. I hope you see that it's a trapezium. It looks like this. Okay, let's just pretend that looks like a trapezium. So that's how it looks. Okay, and if I flip it, well, let me not say flip them. If I rotate it, it's this shape. So it's a trapezium. It's a trapezium that I'm looking at. So if I want to find the value of S, which is the area of this trapezium, we know the formula for the area of a trapezium is actually a half the sum of the parallel sides. So I'm just using this to represent the sum of the parallel sides multiplied by the perpendicular height. Everybody good with that so far? This is a trapezium. I'm trying to find the area of the trapezium, which is S. Do you understand that so far? Please let me
Yes,
know.
miss.
Okay. Okay. I'm going kind of slow, right? Okay. Using these values here. I'll come back to this graph later. Just using these values right here. A half the sum of the parallel sides. Let me just draw this again. This is what it looks like. My trapezium. Yep. That's what it looks like. The parallel sides would be these two sides here. This and this. Those are my parallel sides. What's the value of the parallel sides? Well, from here, it's 0 to 2, right? So this side is 2. Here, it's 0 to 5. So the length is 5. What's my perpendicular height, which would be this? Because this is like a right angle here, right? So perpendicular height, 0 to 4, that's 4. I want to find the area. So this is half the sum of the parallel sides. My parallel sides are 2 and 5. So that's 2 plus 5 multiplied by the perpendicular height, 4. So then you would simplify this and you would tell them what's going on. So that's a half by 7 by 4. And we'll continue all that, right? So that's 40. 40 meters, and that would be your answer, and you move on with life. You continue your paper. That's it. They asked me for the distance traveled or for the displacement. I just found the area of the trapezium, and I told them it's 40 meters. Okay, yay. I move on. Let's go back to this one now. So S, we said, is a half sum parallel sides multiplied by the perpendicular height. So for this, I use actual values. So the 0, the 2, the 5, the 4. But here, I'm using letters. So U, V, and T. Let me use a different color. So S, which is still this area here, the area of the trapezium, is a half by the parallel sides. This side, let me use another color. I'm trying to break this down as much as I can. Let me use yellow. This side is one of my parallel sides. So this is U. This is my other parallel side. Well, anyways, this is my other side, which is V. So that's U plus V. And then here to here, let me use a different color. Is T. So now substituting that into my formula, the sum of the parallel sides, so U and V, U plus V, multiplied by the perpendicular height. Look at this diagram. The perpendicular height was down here, right? Down here, I have T. So T is my perpendicular height, multiplied. But we know we don't necessarily have to put this multiplication sign. If I just leave it like this, I'll have U plus V T. It's implied that this is multiplied, right? Do you understand now? That's how they got the second equation of motion. Can the perpendicular height be the 5? Okay. Before I answer that, do you understand this? Why the perpendicular height cannot be the 5? If I said, I'm not going to clear this because somebody might be writing it down. Let me erase this part. If I consider the 5 my perpendicular height, let me erase some things on this as well. That's good enough. If I consider the 5 my perpendicular height, so this right here, that length is my perpendicular height. Going back to my equation for the area of a trapezium, a half the sum of the parallel sides by the perpendicular height. If I consider this right here, the 5, my perpendicular height, then you're saying that the 2 parallel sides would be here and here. But that's not right, because these 2 blue lines are not parallel. So I cannot take the 5 as my perpendicular height because these 2 blue lines are not parallel to each other. But if I took the 4 to be my perpendicular height, so the 4 is my perpendicular height, then I'm saying that the 2 parallel sides would be here and here. These 2 lines are parallel to each other, so this works. These 2 blue lines are not parallel to each other. That cannot work. Do you get that now? So we identify the parallel sides first, and then the other line is the height. Well, if that's how you remember it, then you go ahead, right?
Yes, you did. How did they get this? Where did it come from? It did not just appear. I already told you that, right? There's always a reason behind something. So what's the reason behind this? How did they get? Well, they actually used our first equation of motion and the second equation to get this. It's a combination of the two. So recall that the first equation of motion, hold on, this is, okay. So recall that the first equation of motion, let me just put this, is V is equal to U plus AT. Second one that we just proved, S is equal to a half U plus V by T. How? How exactly am I supposed to use these two to get this? Using my second one first. I'm simplifying it a bit, right? So S is a half. Let me just put the, actually no, let me leave it T there. U plus, from my first equation, V is the same as saying U plus AT. So therefore, instead of writing U plus V, I can actually write U plus U plus AT. Let me just put this in brackets. And then this is T. All I did, instead of putting the V, I know that V from my first equation is the same as saying U plus AT. So instead of putting the V, I replaced it with U plus AT. That's all I did, right? Simplifying this. Let me just remove the brackets. I just put the brackets to show you that I'm just practically doing a substitution. Simplifying this a bit, right? So S is a half U plus AT. So U plus U, they are two like terms. So 2U plus AT by T. We still simplifying. Let me just multiply the half by the bracket. So a half by 2U, it's U. A half by AT, that's a half AT. But all of this is still being multiplied by T. In blue now, I'm going up here because I have no space. Multiplying the T by everything in the bracket, S is UT, because U times T is UT, plus a half AT squared. That's how we got the third equation of motion. Are you good with that?
Yes, miss.
So you just substituted equation 1 and equation 2. Yes, yes, I did. Can I clear this now?
Yes, miss.
Yes. Okay, nice. Next one. Let's do the V squared is equal to U squared plus 2AS. How did they get that? Actually, no. Let me do the other one. The S is equal to VT minus a half AT squared. Let's prove that one. This one is actually similar to the other one, right? We are still using the first equation of motion and substituting it into the second equation of motion. Let me just, V is equal to U plus AT. Second one, S is equal to a half U plus V by T. Substituting the first one, number 1, into number 2. To a half. This is the only thing that's different. Just now, I substituted V into here. So instead of putting the V, I put U plus AT. For this equation, how they got this equation, instead of substituting v into here, they actually substituted u into here. So using my first equation of motion, I know v is equal to u plus at. But if I transpose and make u the subject, then u would be equal to v minus at. And this is what I'm using. This is what I'm substituting into here. So this would become v minus at plus v by t. Simplify. V and v plus v is 2v, right? So 2v minus at. So multiplying by the t, expand this bracket. So a half by 2v is v. A half by minus at, that's minus a half at. We still have to multiply everything by the t. Don't forget the t. And that's how they got, after simplifying this, s is equal to vt, because v times t is vt. And then minus a half at multiplied by t would give me minus a half. I'm just writing the at squared down here. At squared. That's how they got this. Do you understand that? Yes, no? Would you like me to explain it again? Very similar to the one we just did.
Okay. Yeah, I kind of understand it. But
Kinda.
practice.
Kinda. Why kinda?
No, I do understand it. I do understand it.
Okay. So hold on, let me read the chat. So basically the two verse from there are the fundamentals for all the rest. Yes, basically. Okay, last one. Required to prove b squared. Okay, let me hurry this up. B squared is equal to u squared plus 2ax. That's the last one you need to know. How did they get that? Like I said, it didn't just show up out of nowhere. So we're actually using not the first, the second. Okay, let me, no, I'm leaving it. Actually, no, we're actually utilizing both of them again. So yes, the first two equations of motion are actually the fundamental formula to derive all the others. We're really just manipulating the first two equations of motion to get the others, right? So v is equal to u plus at, and then s is a half u plus v times t. How did they get this? Well, just now, so the last two equations of motion, the first one that I did, well, not the first one, the third one that I did, I substituted the v into equation 2. The fourth one, you substituted u into equation 2. For this one now, we're actually substituting t into equation 2. So s is equal to half u plus v, but we're not putting t, we're going to do a substitution, right? So from my first equation of motion, making t the subject, v minus u would give me at. So t is actually, let me use the therefore sign, t is actually v minus u on a. This is what I'm substituting into my second equation. No, orange. So instead of putting the t, I'm going to put this right here. The v minus u on a. V minus u on a. Everybody good with that so far? Before I continue?
Yes, miss.
Okay. So just simplifying this a bit, right? Let me just rearrange it because I know some people might get trouble with this algebra. I'm just using multiplication signs instead of the brackets, right? So v minus u and a, then this is multiplied by u plus v. Simplify this a little more. I need space, so I'm erasing up here. For the people who know how to simplify this already and get to this point, there's no need for you to have all of these steps. But I know that some people have problems with algebra. So that's the only reason I'm doing all these steps, right? But it's really not necessary when simplifying. Okay, so I can actually say that this is 2a times v minus u multiplied by u plus v. This would become 2as is equal to v minus u multiplied by u plus v. Let me use the brackets in this case. It might be easier for you to pick up on what's going on. So the brackets mean that I'm multiplying both of them, right? 2as. You should actually notice that this is a difference of two squares. Hold on. Again, for the people who might not pick up on it immediately, that's why I'm writing it out, right? For you. Erasing this, erasing this, erasing this, erasing this, erasing this.
Oh,
So
miss,
some
why
people
erase it?
immediately, what?
Why erase it? What was writing down?
Anybody wrote it down? Can you send a picture in the group chat? Or if you took a screenshot, can you send a picture, please?
The WhatsApp.
Right.
Right.
What?
I sent to send to the WhatsApp group.
Yeah. So some people might pick up on this immediately. Okay, v minus u times u plus v, that's difference of two squares. Some people may not, and that's okay, right? So for the people who don't see it, v minus u, okay. Remember what I was just explaining about addition being commutative and it does not matter which order you put it in, it would still be the same. Just like 2 plus 3 is 5, but I can also say 3 plus 2 is 5. It's the same thing. I could switch the order. So instead of saying u plus v, I can say v plus u. Now you might be able to pick up, okay, this is difference of two squares. From my, like I said, it's just for the people who might not pick up on it immediately, and that's okay. Difference of two squares is generally represented like this. So if I have a number a and b, a squared minus b squared is actually the same as saying a minus b by a plus b. That's how I know this is a difference of two squares. So I can actually rewrite my equation to give 2as is equal to v squared minus u squared. And all they did here, they just transposed to make v squared the subject of the formula. Well, the subject of the equation. So v squared, add u squared to both sides. So u squared plus 2as. And that's how we got the final equation of motion. Do you understand that? Yes, no. Is there any line at all that you don't understand? How did you get rid of the denominator, which was a? This right here, this line? Okay. Hold on. Yes. I'm erasing this. So in the line before, I had written S is a half multiplied by V minus U on A multiplied by u plus v. And just put brackets. Right. Multiplying two fractions. 1 multiplied by v minus u is v minus u. And 2 multiplied by a is 2a. And then we still multiplying by our u plus v. If I multiply both sides by 2a now, I would end up with 2as. So that's me multiplying the two sides by 2a. So I'll get 2as. The 2a would cancel with this one. So I'll end up with v minus u multiplied by my u plus v. Do you get that now? Oh, you still don't understand. Okay. Can I clear the screen now? Is it okay if I clear the screen? See? Is someone talking? It sounds like a whisper.
No, I say yes. You
Okay.
can clear it.
Okay, now that we did that, we finally finished that. Rejoin because we have less than a minute, but then we're going to do past papers, right? The rest of the class is just past papers. And